All right, exoplanets. I know it sounds like something out of Star Wars. But these aren't science fiction, right? We're talking about real planets orbiting other stars
Yeah.
out there in the universe. And get this, we've already discovered thousands of them. Thousands.
It really is incredible.
It is. You're probably wondering how we even find these hidden worlds. Yeah. And what kind of planets are out there? Could any of them, be home to alien life?
The big question.
Yeah. Those are exactly the questions we're going to tackle in this deep dive. So get ready, because we're about to uncover some truly incredible cosmic wonders. Like, we're talking planets with lava oceans and rogue planets just wandering the galaxy all by themselves.
Yeah, it's mind-blowing to think that just a few decades ago, the existence of exoplanets was purely theoretical. I mean, humans have been looking up at the stars and wondering about other worlds for, well, centuries, really, but it's only recently that we've been able to actually detect them.
It feels like we're living in this, like, golden age of discovery.
Oh, absolutely.
I'm curious, though, where did it all begin? Like, what were some of those key moments that sort of kicked off this whole exoplanet craze?
Well, the first confirmed discovery of exoplanets that happened in 1992. And these early finds were orbiting a pulsar, which, it's a really strange object, a super dense, rapidly spinning neutron star. Not exactly a typical solar system.
Yeah, pulsars are pretty extreme environments.
Definitely.
So when did we start finding planets around stars that were more, well, normal? Like more like our sun?
Yeah. So the real game changer came in 1995 with the discovery of a planet called 51 Pegasi b. And this was the first exoplanet that we found orbiting a main sequence star, similar to our sun. And it was a monumental discovery. It really kicked off this whole field of research. And since then, I mean, the floodgates have opened. We've gone from a handful of known exoplanets to over 5,000. And that number just keeps climbing.
5,000 exoplanets. Wow. But, okay, here's the thing that's always baffled me. How do we actually find these things? They're incredibly far away.
Yeah.
And they're totally dwarfed by the blinding light of their stars. It's like trying to spot a firefly next to a spotlight from across a huge stadium. You know what I mean? How's that even possible?
Direct imaging, actually taking pictures of these planets, it's incredibly difficult. It can be done, but only with very specialized telescopes that have something called a coronagraph. And that blocks out the star's light, to reveal those faint little specks of planets orbiting around it. But even then, that technique is pretty much limited to larger planets that are relatively far from their stars.
So if we can't just, snap a photo, how do we find most of these exoplanets?
Astronomers have gotten pretty clever. There are a few main methods, and each one relies on slightly different techniques and kind of reveals different information about these distant worlds. So let's start with one of the most successful methods, the transit method.
Okay, the transit method. Lay it on me.
Okay, so imagine you're looking at a star, right? And a planet passes in front of it from our point of view here on Earth.
Kind of like a mini eclipse.
Exactly. Even though the planet is tiny, compared to its star, it blocks a little bit of the star's light as it passes by.
Makes sense.
And sensitive telescopes, like the Kepler Space Telescope and the TESS telescope, those are specifically designed for exoplanet hunting. They can detect this tiny dip in brightness. And that dip, that tells us there's a planet orbiting that star.
Pretty ingenious, really. And I've heard that these transit observations, they can even tell us something about a planet's atmosphere. Is that right?
Yeah, that's right. When a planet transits its star, some of the starlight passes through the planet's atmosphere on its way to us, and different gases in the atmosphere absorb different wavelengths of light. So by carefully analyzing the spectrum of the starlight that reaches us during a transit, we can actually identify what gases are present in that planet's atmosphere. We're talking about things like water vapor, methane, even oxygen.
Wow, so we're not just finding these planets, we're getting glimpses into what their air is like.
Exactly.
That's incredible. But you mentioned other methods, right? What else do astronomers have up their sleeves?
Right. Another really effective technique is the radial velocity method, sometimes called the Doppler method.
Doppler, like the Doppler effect. That's where a siren sounds higher pitched as it's coming towards you and lower pitched as it moves away.
It's the same principle, exactly the same principle, but with light instead of sound. So a planet's gravity tugs on its star, right? And it causes the star to wobble slightly as the planet orbits. Now, as the star wobbles towards us, its light waves get compressed, making the light appear slightly bluer. It's called blue shift. And when the star wobbles away, the light waves stretch out, causing a red shift.
Got it. So by measuring these tiny shifts in the star's light spectrum,
Mhm.
we can detect the wobble caused by an orbiting planet.
Exactly. And this method, it's particularly good at finding massive planets, the ones that exert a stronger gravitational pull on their stars. In fact, that first exoplanet we talked about, 51 Pegasi b, that was discovered using the radial velocity method.
This is amazing. We've gone from wondering if other planets even exist to actually studying their atmospheres and measuring the wobbles they cause in their stars.
I know.
It's incredible. But wait, I know there are like a couple more methods for finding exoplanets. What are those?
Right. Well, we talked about direct imaging, which is amazing when we can pull it off, but it's limited. Another method, which is maybe a bit more complex, is called gravitational microlensing.
Okay, gravitational microlensing. Now I'm intrigued, but I have no idea what that means.
All right. So imagine a distant star way out there in the galaxy. Now imagine a nearer star passes in front of it. From our perspective, the gravity of that nearer star actually bends the light from the distant star, acting like a magnifying glass.
So the distant star appears brighter
Hmm.
for a short time, and that's because of the gravity of the star passing in front.
Yes, it's like the universe is giving us this cosmic magnifying glass. And here's where it gets interesting. If that nearer star has a planet orbiting it, that planet's gravity adds this like little extra lensing effect. It causes a second, smaller brightening of the distant star, and we can detect this tiny blip in brightness and use it to infer the presence of the planet.
Well, that's really cool. So what kind of planets are best suited for this microlensing method?
It's particularly good at finding planets that are very far from their stars. It can even detect rogue planets.
Rogue planets. Tell me more about these rogue planets. But first, I think we need to like take a moment to let all of this amazing information sink in.
So rogue planets, these are planets that, well, they don't orbit a star at all. They're just drifting through the galaxy all on their own.
They sound like cosmic nomads, these lonely wanderers.
Hmm.
How does a planet end up going rogue in the first place?
Yeah, it's a good question. So they probably formed in a star system, like any other planet, but then something dramatic must happen. Maybe a close encounter with another planet, a really massive one, or even a passing star. And the gravitational forces from that kind of interaction, that could have been enough to like kick the planet right out of its solar system, sending it off into, well, the vast emptiness of
So
space.
they're just out there, just drifting in the darkness. A sad thought.
Yeah, I guess it might seem that way, but here's where it gets really interesting. Some scientists think that rogue planets, they could still potentially harbor life.
Wait, really? But don't you need a star? Like to provide warmth and energy for life to exist?
Well, that's true for life as we know it here on Earth. But some rogue planets, right, they might have internal oceans, and these oceans are kept warm not by sunlight, but by radioactive decay. And that's happening deep within their cores. I mean, it's definitely a long shot. But it's not impossible that some form of life could exist in these hidden, subterranean oceans completely independent of a star.
Wow. Okay, now that is mind-blowing. Life on a rogue planet drifting through the galaxy. But rogue planets, I mean, they're not the only weird and wonderful worlds out there, are they? You were mentioning some other pretty bizarre types of exoplanets earlier.
Oh yeah, we've barely scratched the surface. Remember how we talked about how like our own solar system, it's actually pretty unusual compared to what we're finding out there. Like one of the most surprising discoveries has been these hot Jupiters.
Hot Jupiters.
Imagine like a gas giant like Jupiter, but orbiting so close to its star that its year only lasts a few days.
I bet it's hot there.
Yeah, they're blasted with this intense heat and radiation.
Oh, I can only imagine the weather.
You could say that.
Yeah.
One example is this planet called WASP-12b, and it's so close to its star that the star's gravity, it's actually stretching the planet into an egg shape. It's slowly pulling it apart.
Oh, that's rough. WASP-12b is not having a good time. So are hot Jupiters common, and how do they even form so close to their stars in the first place?
Well, they're more common than astronomers originally thought. We found quite a few of them, and their existence, it really challenged our understanding of planetary formation. It's thought that they might form further out in their systems where it's colder, and then over time they kind of migrate inwards because of these gravitational interactions with other planets or the protoplanetary disk.
Right, the protoplanetary disk. That's that swirling cloud of gas and dust, right? The one that surrounds a young star and eventually gives birth to planets.
Exactly. It's a chaotic environment, and planets, they can jostle for position and migrate inwards or outwards during the early stages of solar system formation.
Fascinating. So we've got these rogue planets just wandering the galaxy. and then these hot Jupiters getting roasted by their stars.
Yeah.
What other crazy exoplanets are lurking out there?
Well, there's this whole category of planets called super-Earths, and they've really caught the attention of scientists.
Two Earths. Okay, that sounds promising. Tell me everything.
So these are planets that are, larger than Earth, but smaller than Neptune. They're kind of in that uh, Goldilocks zone of planetary sizes, and they could be rocky planets, like Earth, or ocean worlds completely covered in water. And some of them might even be habitable.
Habitable. Now, you're speaking my language. What's an example?
One of the early discoveries that really got people excited was Kepler 22b. It's a super Earth that's orbiting a star very similar to our sun, and it's right like smack dab in the middle of that habitable zone.
The habitable zone. Okay, so that's that sweet spot where temperatures are just right for liquid water to exist on a planet's surface.
Right. And liquid water, that's essential for life as we know it.
Okay, I'm already picturing like these lush alien landscapes on Kepler 22b, but I know it's not that simple, right?
Yeah.
Just because a planet's in the habitable zone, that doesn't mean it's like automatically teeming with life.
Yeah, you're right. There are a lot of other factors that come into play, like the planet's atmosphere. That's crucial. Does it have a protective ozone layer? What's the atmospheric pressure like? And does the planet have a magnetic field to shield it from, harmful radiation from its star? All of these things can affect whether a planet is truly habitable or not.
It's amazing how complex it all is. It's like this cosmic puzzle,
Hmm.
you know, and we're just starting to put the pieces together. But you know what I'm really curious about?
What's that?
How do we actually search for signs of life on these distant worlds? I mean, we can't just send a rover over there to like take a look around. Well, at least not yet.
Right. That's where this concept of biosignatures comes in.
Biosignatures. All right, tell me more.
So these are gases in a planet's atmosphere that could, indicate the presence of life.
Like oxygen. We need oxygen to breathe. So finding it on another planet, that would be a pretty big deal, wouldn't it?
Yeah, it would be a strong indicator, especially if we found it alongside other gases like methane. These gases, they can be produced by biological processes. So finding them together in a planet's atmosphere, that would be pretty compelling evidence for life.
So we're basically sniffing out alien atmospheres
Mhm.
for signs of life. That's incredible. But how do we even do that from, light years away?
Well, we have these incredibly sensitive telescopes and this spectrographic analysis. Remember how we talked about analyzing starlight passing through a planet's atmosphere during a transit? Well, that's one way to do it.
Right, right. We can like tease out the chemical fingerprints of different gases in the atmosphere.
Exactly. And telescopes are just getting more and more powerful. Like the James Webb Space Telescope, it just recently launched. It's already making incredible discoveries. And future missions like the Roman Space Telescope and the Extremely Large Telescope, these are going to be even more powerful, allowing us to study exoplanet atmospheres in even greater detail.
It's amazing to think that we've gone from wondering if there are other planets out there to actually searching for signs of life on them.
Hmm.
Like science fiction is becoming reality right before our eyes.
I know, it's truly remarkable. And this is just the beginning. Every new exoplanet we discover, it teaches us more about the universe and our place in it. And who knows, maybe one day we'll find that definitive evidence that we're not alone.
Okay, you've officially blown my mind. There's so much to learn, so much to discover out there. I can't wait to see what the future holds for exoplanet research. But before we get too far ahead of ourselves, let's take a moment to just appreciate the journey we've taken so far.
I agree. From those first, those tentative discoveries to the incredible diversity we're seeing today, it's been an incredible ride.
It really has. And I think it's time to delve into, maybe the biggest question of all. Are we alone in the universe? So are we alone in the universe? I mean, with all these thousands of exoplanets out there, it seems almost impossible, right? That Earth is the only place where life has actually taken hold.
Yeah, it's a question that has fascinated humans, well, probably forever, right? And now, thanks to exoplanet research, I think we're finally starting to get some clues. I mean, while we haven't, found definitive proof of alien life yet, I think, what we are discovering is incredibly exciting.
So where do we even like begin to look for life beyond Earth? What are the key things that scientists are looking for?
Well, one of the most important concepts is this idea of the habitable zone. Sometimes it's called the Goldilocks zone.
Right,
And it's this region, right, around a star where temperatures are just right, not too hot, not too cold for liquid water to exist on a planet's surface.
right. Liquid water that's essential for life as we know it, at least.
Exactly. So finding a planet in that, sweet spot, that's definitely a good starting point. And one example that's really captured a lot of attention is Proxima Centauri b.
Proxima Centauri b.
Okay.
That's the planet orbiting the closest star to our sun.
Yep, that's the one.
Is that right?
Yep. And it's right there in the middle of the habitable zone.
Okay, so I mean, are we talking like little green men on Proxima b?
Well, hold on, hold on. It's not quite that simple. Just because a planet is in the habitable zone, that doesn't guarantee that it's, like teeming with life. It just means that it has the potential for liquid water, which is a crucial ingredient. But there are a lot of other factors that we have to consider.
Like what?
Well, the planet's atmosphere, that's crucial. Does it have like the right mix of gases to support life? Is there a protective ozone layer to, shield the surface from all that harmful radiation? And what about a magnetic field to deflect charged particles from the star? All of these things can really affect whether a planet is truly habitable or not.
It sounds like a lot of things have to like fall into place just right. So how do we know if a planet has, the right stuff? We can't exactly like fly over there and take a look, at least not yet.
Right. And that's where this concept of biosignatures comes in. And these are specific gases in a planet's atmosphere that could, indicate the presence of life. Remember how we talked about how we can analyze the light passing through an exoplanet's atmosphere? Well, that's one way to actually search for these biosignatures.
So what kind of gases, are we looking for? I know you mentioned oxygen earlier.
Yeah, yeah, oxygen is a big one, especially if we find it in combination with other gases like methane, for example. These gases, they can be produced by biological processes. So finding them together, in significant amounts in a planet's atmosphere, that would be pretty strong evidence that something is alive down there.
It's mind-blowing to think that we can, actually analyze the air of planets that are light years away.
I know, it's incredible, and the technology is just it's constantly improving. I mean, like the James Webb Space Telescope, that's already making amazing discoveries, and upcoming missions like the Roman Space Telescope and the Extremely Large Telescope, those are going to be even more powerful. They're going to allow us to study, exoplanet atmospheres in even greater detail.
It feels like we're on the verge of something like truly groundbreaking. In just a few decades, we've gone from wondering if there are other planets out there to actually searching for signs of life on them.
And this is just the beginning, right? I mean, every new exoplanet we discover teaches us more about the universe, more about the incredible diversity of worlds that exist out there.
So after this deep dive into the world of exoplanets, I mean, what's the biggest takeaway that you hope people will kind of leave with?
I hope people come away with a sense of wonder, a sense of wonder and a renewed appreciation for the vastness and the mystery of the universe. We've learned that our solar system, it's not the norm. There are countless planets out there, many of them far stranger, far more wondrous than we could have ever imagined. And the possibility that we might not be alone, in this vast cosmic ocean, well, it's both humbling and exhilarating.
Well said. I think we've given everyone a lot to think about. Thanks for joining me on this incredible journey, this deep dive into the world of exoplanets.
It's been my pleasure. Keep looking up at the stars and never stop wondering what else might be out there.